Hey again. Yeah, we're back again, guys, because I started doing the video and messed up and didn't record. So we're back again. We're doing another video on another Node MCU internet module that's going to monitor something on my aquaponics system, and you may want to use in yours. I'm actually going to integrate this into an existing module, my Sump module out there, but to do testing and everything, I did it on a breadboard here with the node. And what I probably will do is, because the sump alarm, I actually soldered to a board. And if it's going to be too difficult to solder this crap on there, it shouldn't be, but I might just transfer it over to this board. But anyway, we're doing and I got to be careful, the pins don't pop up here, a water flow alarm, a water flow sensor. It's not, what it does is it will actually, and it just popped out, my pins, and just give me an alarm for doing that. I'll show you here on the iPad. I set it up to send two things to my, let's get rid of that, to my little app here. The first one, well, first of all, there's the an LED. It'll be red whenever the water flow is at basically 1 or below, or basically 0, no flow. It's going to be red. And it sends that alert you saw me clear out there. It sends an alert saying the pump's not running. And that's what I want it for. I want it to tell me my pump is, for whatever reason, not flowing. But it also gives me this number here. It's going to give me a number that's going to represent the water flow. It's supposed to be liters per hour, but that's per the code I'm using. But I don't know if it's calibrated, because all sensors are different. And I have to get the data sheet and see if it can match numbers. I might be able to tweak it so it will match. But I'm not concerned about how many liters per hour I'm pumping out. If you remember my last video, or not last video, but some videos ago, on my sump tank where the water pump's at, it's coming out at 1 inch or 1.5 inches. I forget which. So, and this is a 1/2 inch water flow sensor. I think I found a couple, and I don't recall, some larger ones, but they were really expensive. This one was only $10, I think. And it's got 3 wires out, a positive, a negative, and then in the middle one is data. And what it does is it uses a magnetic sensor there on the fan that would surround and sends pulses out, which represent your water flow. So I'm gonna, if you remember again, my sump, the water comes up out of the 1 inch, but I also have a bypass of a 1/2 inch going right back down in the sump. And I use that to take pressure off the system if I need to adjust pressure. What I'm gonna do is I'm gonna just connect this there, turn it on a little bit, and let the water flow. And that will give me indication that everything's working hunky-dory. What I might also do is take note of, I just cleaned my filter bag over the pump. Just cleaned it out. So right now it's a pretty good flow. It's probably the top it's going to be. So I'll take note of that number, and then I can make adjustments in my code. So if that number gets to be, it will start, as it gets dirty, it will start to come down. You know, the flow will start to come down a little bit. So I can set a point where I want an alert or change the color of the water flow or whatever. So it will tell me it's time to go clean the pump bag. So again, automation, so I'm not checking all the time. I'm lazy AF. So anything to make life easier. So let me show you real quick how this works. And then I'll go into the wiring of it, because the wiring was a pain in the butt. The code was really a pain in the butt. So normally this is a female. I put some pins in here to go into the breadboard. So I'm going to plug this in right here and hold it, because otherwise it'll fall out. It's giving me an alert because it's at 0. I'm gonna blow into it on some, like a water flow, because this works for air too, and I am considering putting some of these on my air pumps as well to make, let me know that I have airflow into my water, my fish tanks. The important part. But I think I did find a 1/4" one, and it's not much. It's around the same price, so I'll probably do that and run 1/4" lines to my fish tanks and then take it down to 3/16. Anyway, let me do this and I'll show you on the app. And it has to go in a certain direction. Oops. So you can see real quick, it's green there, has a number, it's going down to 0, goes into alarm, gives me the notification that it's not flowing anymore. So there's that. I'm going to unplug this because it's too much to hold on to. So wiring for this puppy is a little bit tricky, and it's kind of hard to visualize here and show you. But the water sensor wants 5 volts, and then it takes the 5 volts across a voltage divider. And here's where I don't know the whys. I just know I found it. It works. We'll go with it. So what we have here is we're taking the 5 volts out of the, well, first we're taking the ground, and the ground's going directly to the sensor ground. And the power, now if I'm going to bring power in from my power supply, the power supply voltage would go into these pins as well. Or right now my sump alarm is powered by USB, so I might just leave it that way. So the positive voltage out, the 5 volts, is going into this section of my breadboard, which is just power, all positive one side, all negative one side. So the 5 volts is going it's going straight here in the orange jumper to the positive of my sensor. That's powering the sensor. It's also coming to this 10K resistor, one leg of the 10K resistor. And then that goes through the resistor, and on the other side of the resistor, here's the tricky part, we're going to the sensor data. We are also going on the green wire to the sensor input on the node, which I'm using pin 4. And then it's also going to this brown wire to 5 volts. Don't ask me the whys, it just works. So I don't know if you guys are going to be able to remember it. If I get a chance, I'll post a picture of it down below to a URL or something. I'll figure a way of doing it down, but it might not be right away. But you can always ask me questions if you need help on doing this. So that's the wiring of this. And again, like I said, I'm going to incorporate it with my sump pump alarm, which is using pin 1 right now. So that's why I use pin 4. I know that's free on that board. So hopefully this records. Like I said, I hit stop recording last time and I lost it. We're going to jump over and I'm going to screen share and show you the code for this as a standalone. And then as I get it incorporated into the sump alarm, I'll show you the code and the wiring of all that together in a little bit. All right, hold on. Hey guys, we're back. And if you see in front of me, if you remember from the last video with the ultrasonic sensor, this is Arduino IDE, which is used for writing your code and uploading it to your modules. You just plug in, and I'm down here in the right-hand corner. You just plug in your module with a USB cord to your computer, and you hit upload, and it puts the code in there, and then it starts to do its thing. The left here is my sump alarm currently, and that's what I gotta integrate this right-hand code into that. And basically what I'm going to be doing is taking, the bits and the setup, and it's not too difficult, but you got to test it and make sure it all works. But let's go over the right hand here. Again, I don't understand a lot of the code. I just, copy and paste what I find. If it starts to work, then I can put the blink parts into it. And blink, again, is the app that you use for monitoring all this stuff, and it is blynk.cc. It's pretty much free. If you build a big app, you're going to pay a little bit for the extra widgets, but and I explained that in the last video, but it's well worth it. So what I did here, of course, this is all the blink stuff up top, all the stuff and you need it included, your Wi-Fi credentials. What I did here is I'm defining the LED, and the data is going to be put on virtual pin 2. So when I do the app I assigned the LED to virtual pin 2. I'm defining the colors for the LED, red and green. I'm defining the flag, and what the flag does, and I found this at the hard way last night, is basically when you do this code, every second it's going to go get the data and then do what it's supposed to do. Well, I had it so if it hit 0, it sends me an alert. Well, every second it was doing that, and it got very annoying. So you put a flag in there, so if it does it the first time, it sends you the alert. It switches the flag to on, we'll say, to a 1. It starts off as 0, sets it a 1. So the next time it comes through that loop, it's still a 1. It doesn't change to a 0 again, so it doesn't send the alert out again. So it works. Now all this code right here, I copy and pasted. I have no clue, but it's basically running the sensor. And then like, let's see, this is just defining things, defining the variable calc, which is my end result, defining Hall sensor as the stuff that comes in pin D2 on my node, which is actually pin 4. It's working on pin 3. Go figure. It works. Like I said, I'm not. I don't know why it works. I'll have to check the pin out. Maybe that's what it is. And then this is telling blink to start, and this is the timer to work to tell the timer to start, and every 1 second to run the get data, which is down here. And then the void loop, again, keep it small there. Blink like's not much in there. It's telling to run the timer. Now this is the data here. You know, it sets the this variable to 0, and then it gets the stuff, magic, you know, voodoo from the sensor. It prints it serially. You can see here the serial printed out. I'm going to clear the output, but you can see it's not flowing right now. But let me go ahead and show you. Make sure this is lined up the right way so we don't short everything out. Pop the pins out. There we go. We'll blow on it and you'll watch the numbers move. And then it goes back to 0. I'll get an alarm. Blah, blah, blah. So that's what it's doing down here after it does all the calculations. It will print serially here, which that's just for debugging. But it will take right here and it will the blink virtual write to virtual pin 10, write the value of calc, which is right here. Calc is the flow rate, supposed to be liters per hour, who knows. So it writes it to the virtual pin, so that virtual pin gets picked up and puts it in that, a lot of alarms to clear up. And then down here, it's going, if calc is less than or equal to 1, and or not and, I don't know what that means, but then the flag does not equal 0, then send the alert, turn on the LED and make it red, and then set the flag to 1, and then blink alert, send the alert to my pump. This sends it to the serial port, this sends it to the app. Else, meaning if it's not 0, then it will, I put it else if it's greater than or equal to 2. It'll reset the flag to 0. It'll turn the LED on and turn it to green. And that's all there is to it. You know, like I said, I went and found all this crap that does the calculations, copy and paste it, and then this part of, I'm that smart that I know how to write this part in Blink to get that to function. Now, basically what I'm going to do is I'm just going to copy part to part. You know, the parts I have here that I don't have over here, which is the pin mode for the Hall sensor, the interrupt. I'm going to take those two and put it in the setup over here. And then I'm going to take this whole void get data. I'm probably going to just take this stuff and put it over here in the, I don't have it over here. It's in the setup, but I'll figure that part out. We'll get that later. But to make it one module. So that's what I'm going to do right now. I'm going to end this part of the video. I'm going to go out there, bring in my sump pump, play with it, see about how getting all that wiring into that breadboard, or actually it's a regular board out there. Solder if I have to. If not, I'm going to turn this into the sump pump on the breadboard, which will probably be faster and easier. And then you just desolder that module out there so I can use it again. And away we go. So I'll talk to you guys later, and I'll show you the final product in the next clip. See ya. Alright, where's my little, there it is. Well, after a quick trip to Lowe's and Chick-fil-A, I'm hungry there. But yeah, get out here and think of all the fittings I have for PVC. I didn't have a slip to thread for 1/2 inch. So it's in place. I got it flowing, not a lot, because I didn't want to take a lot away from the system. Here's the final version. I went ahead and just took the breadboard and added the sump alarm to it right there. And it's going to pins 1 and ground. So when it grounds pin 1, when the alarm sump water goes low, it sends me an alert and turns my little red light or green light to red. And here it is on iPad. It keeps on flashing to a real high number. I'm not sure what that's all about. I'm not going to worry about right now. I might later on bring it back in the house and redo the code a bit. But yeah, it bounced a little bit because it's kind of bouncing there, so I can understand the fan bouncing. I can turn on full blast, and let's go ahead and do that. Get over here and let's increase the flow. Flow increased. They're nice and steady out, and then according to the software, it's 512 liters an hour. I don't know what it really means. I'll have to figure that out later. I don't want it that high. I just needed enough flowing so it tells my app that the pump's working. And it's down to 256. We can probably go a little bit lower. Yeah, I'll leave it there. I think that's good. I'll check the flow of the rest of the system later. But that shouldn't do anything. And if I notice a sudden decrease, not these little flashes I get, but a sudden decrease, I can also change the, right now it's checking every second. I might run it inside the house and change it every 5 or 10 seconds, because it doesn't need to be checking every second. And that's what's giving me the fluctuations every second. So I might take it in the house real quick and change the time to every 5 seconds or so, and live with that. And the green lights tell me the pump's running as well. So I'm gonna do that. I'm gonna unwire it, take it inside, change the timer, and then reconnect it and put it inside of its little box, and I'm done for the day. So that's it for this video. If you want, we'll just do a quick run through. Not really talk to you, but just to show you where we're at with everything today. Now the lettuce and the strawberries. A lot of strawberries. I'm getting ready. I'm going to add the second pipe on the other side and get some more. Basil's going bolting. Get some strawberries down here. That's not basil, that's spinach. Basil. This basil's a bolting. Lots of kale go around here. Bell peppers. Cucumbers. Zucchini plant's coming back after I trimmed it all the way. So hopefully I'll get some more out of there. I need to trim these leaves off. peas, broccoli, cauliflower, lots of tomatoes. Look at them ripening over there. Ripening over here. And I'll show you this more in detail in another video, but got the second side going here all the way except for the last bed. So that's it, guys. Any questions, comments, please leave them below. Subscribe, like, you know, all the YouTube stuff. And I hope you guys have a great Memorial weekend. I'll be working out here and other stuff. I got some projects going with the trees to start working on. And replacing some fencing in the front. So, I will talk to you guys later. I just wanted to take a moment to formally apologize for that last bit to this video. I was shooting it this way. For some reason it came out that way. I don't know why. I just got a new iPhone. And that was the first video I shot on it. So again, I apologize for the orientation. Have a good week.